Hello, welcome to Engineer's Mindset. Now in this video, I'm going to show you a shortcut to differentiate logarithmic functions. Let's say I have y is equal to log x squared and I'm asked to find the y, the x. Now this is the shortcut. To differentiate a logarithmic function by shortcut, what you do first is this: differentiate the variable in front of the log function. After differentiating this variable, use that derivative to multiply the reciprocal of what that same variable in front of the log function. For instance, if I differentiate x, I will simply have 2x. Use this derivative now to multiply the reciprocal of what? The variable in front of the log function, which is x squared. So I'll simply have 1 all over x squared. So this means that the x is now simply what? 2x all over x squared, which is actually what? Okay, x here strikes 1. I'll simply have 2 all over x. And that's how to differentiate. Okay, that's the shortcut. Let's try another example now. Let's say I have y to be equal to ln cos x. It doesn't still change, it's still the same rule. First of all, differentiate the function or the variable in front of the log function. Okay, so I'll have that dy dx is now equal to, if I differentiate cos x, I will simply have minus sine x. So this is simply minus sine x. Okay, use this derivative now to multiply by what? The reciprocal of that same variable in front of the ln. So it becomes 1 all over cos x. Therefore, the x is simply what? Minus sine x all over cos x, and that's simply what? Minus tan x. So you simply have this. Let's try one more example and see. Alright, so even exponential functions are also not exempted from this. Let's say I have y to be equal to ln exponential x squared. Okay, so first thing first, okay, the x is now going to be, recall, to differentiate an exponential function, I said, okay, so first thing first, we have to differentiate the variable in front of the ln, and that variable is simply what? Exponential x squared. So please look up my video on shortcut approach to differentiating exponential functions for proper understanding. But to differentiate an exponential function, I said, simply what? Differentiate the power, use that derivative to multiply the exponential function itself. So I want to differentiate exponential x squared. X squared is the power of this exponential function. If I differentiate x squared, I will simply have what? 2x. Use this 2x to multiply the exponential function. That simply gives us 2x exponential x all squared. So this becomes what? The derivative of exponential x squared. That's the first thing. Differentiate the variable in front of it, then use the derivative now to multiply the reciprocal of that what? Function. So we simply have 1 all over exponential x all squared. So this is saying that the x is also equal to 2x exponential x squared all over exponential x squared. So notice here that exponential x squared strikes exponential x squared. I now have that the x is actually equal to what? 2x, which is same answer. Okay, let's try a different method to solve this same problem and see. Okay, so you know that from y equals ln exponential x squared, you know that ln is same thing as what? Log to base e. Okay, this is what ln means. Ln simply means log to base e. That's a natural logarithm. So this actually means that y itself is now equal to, in place of this ln, we are simply saying log to base e of what? Exponential x all squared. So this is what you have. And of course, from the rule of logarithm, I can simply say y is equal to, simply bring down the power down. So I have x squared log e to base e. And of course, when a log has the same number as the base, it's actually what? 1. So this simply means that y is simply what? X squared times 1. and therefore y is equal to x squared. So which means the x is actually what? 2x, which is the same thing as what we obtained here. All right, guys, that's how you differentiate exponential functions by shortcut approach. I hope you find this video very interesting. Please, if you do, I would like to get your thoughts in the comment section. Please keep it locked on this channel, and if you're new, please don't forget to hit the subscribe button to keep getting more updates on content like this. Thanks, guys, and cheers.